Hello, and we're back again to talk today about significant figures. And so, significant figures are basically digits that carry meaning and contribution to its measurement resolution. Or the harder term is digits in any measurement that are that one known with uncertainty plus one digit that is uncertain. And so, let me get this started. Sig. For sure, we'll just call it sig figs for now. Sig figs. Okay. And of course, I'm pretty sure as all my audience knows that sig figs come with rules. And the first rule one of sig figs is that digits 1 through 9 always count. So 1 through 9 digits count. Okay, give me 1 second. Erase this. I'll rewrite that again one more time. Rule 1 through 9 digits count. Okay, so let me give you an example. So let's say, for an example, we have 14.32. Well, obviously, this is one digit right here. That's another digit right here. That's another digit right here. And that's another digit right here. So that would equal 4 sig figs. Okay, one more. Let's say we have 3.17. That equals 2 digits. That equals 3 digits. 3 digits. Yeah, just gotta erase it. Okay, then. Where's my eraser? Sorry about that. Let's erase this. Alright. Equals 3 digits. Okay. So let's say now that we have, I don't know, 2.473672. How much would that be? If you said 7, you're correct. That'll be 7 digits. Alright. So now that you got rule 1, let's go to rule 2. Rule 2 of the significant figures is leading zeros are never significant. So leading zeros are never significant. Okay, so basically what this means is, let's say for example we have 0.00079. These right here, let me get like a red color. These colors right here, those are not going to be significant because they're leading zeros. But these two numbers right here, the 7 and the 9, they're going to be significant. So that would make that 2 significant figures. Okay, another one, 0. Let's see, 0.73. I don't know, just something random. This again would be 2 significant figures. Oops, 2 significant figures. Okay. 0.07321. How much this time? You said 4, you're right. These are really basic. It takes memorization to memorize them. I wouldn't make this hard. Okay. Now, rule number 3. Rule number 3 is confine zeros, or in other words, zeros that are in between non-zero digits are significant. Give me 1 second, I'll give you an example. Okay, so for example, let's say 2.075. What would you think of this? Well, because this zero right here is in between the 2, the 7, and the 5, it's going to be significant. So it's going to be 1, 2, 3, 4. That's 4 digits. So that's four significant figures. Okay. Another example. Let's say we got 20.83. Another 0. So that's 1, 2, 3, 4, 4 again. Okay, let's say we've got, I don't know, 2,000.8. 1, 2, 3, 4, 5, 6. 6. Simple. Simplicity is the key, and this isn't as hard as it seems. It's easy. All right, rule 4. This is where it starts kind of getting not tricky, but a little tricky. So rule 4 is trailing zeros are sometimes significant and sometimes not significant. But I made it my own rule, so trailing zeros with a decimal point are significant. So with decimal point is significant. There we go. Okay. So trailing zeros with decimal point are significant. So what I mean by that is, let's say we have 62.00. Now automatically you think 6 and 2 are obviously significant, but you don't think about these two. They don't look like they have any significance to them, but it's trailing and it has a decimal point, so it's obviously gonna have to be significant, so it's gonna have 4 significant figures. So let's say now we got, I don't know, 27.20. 1, 2, 3, 4 again. 4 significant figures. Okay, so now one last example. Let's say we have 47,000.000. How much would that be? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on, I think I miscounted. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9. My bad. You know, 9 significant figures, and that's it. Last rule is rule 5. And what rule 5 is rule 5 is trailing zeros without a decimal point aren't significant. So rule 5, trailing zeros without decimal point. Decimal point aren't significant. Forgot the I. And what I mean by that is, so let's say we have 63,300 and 63,300,000. This, you'd obviously think that 1, 2, 3, 4, 5, 6, 7, 8. There's 8. But no, because if there's no decimals in this answer, it's not significant. The only significant numbers are the one that's 1 through 9, and that's 1, 6, that's 6, 3, and 3. So that'll be only 3 significant figures. Because these are the only numbers that are 1 through 9, and because all these digits came without a decimal point. Okay, I'll give you 2 more examples. Another example of this is, I erased it, doesn't matter. Let's just 67,000. Again, no decimal point, that's a comma. You see the comma, it means no decimal point, so that means it'll just be 2. But what if you see something like this, 67,000 point? What if you see a decimal at the end? What do you do then? Well, that's a good question. What you do is you count them anyways. You count all of them. 1, 2, 3, 4, 5. So it's 5. You counted five because the decimal point is there. Decimal point makes a big difference. And if it's there, you're going to count the points. If it's not there, you don't count these zeros. And that's it. The next video I'll give y'all some more examples if y'all want, but I think this gives a pretty good summary of what to do. All right, that's it.